For those of you who don't know Bob, there are big brains, there are really big brains, and then there's Bob. So I've known Bob for many, many years, and he was one of the earliest advisors on Satoshi Energy. Back when I was investing in that for the very first time, everyone thought we were all nuts. Bob was the guy who was like, no, I did the math, it works. And I was like, all right, if this guy says it works, it probably works. Similarly, when I saw him working with Calvin now on mining in space, everyone else laughs, it's impossible. Bob did the math, said it works. I'm like, all right, probably is going to work again. So that's how I know Bob. I think he ran mining at Fidelity a long time ago, was at CERN. If you guys ever heard the Large Hadron Collider, I don't know if you did a little something with that. Smart guy. Yeah, cool. So there's two things I want to riff with Bob on. One is we've given you so far today a lot of this vision of scaling laws going really, really big. And I want to hear Bob as somewhat of a contrarian case. And I thought it was important that we voice that, given that I respect Bob's opinion a lot. And then we'll touch very briefly on digital life, and that'll be that. So Bob, what is the contrarian case you think we should be considering that we're not just blindly optimistic?
Yeah, so kind of the underlying thesis of this conference has been that the AI guys in particular are going to show up and need terawatts of power. I want to present to you the idea that this is not going to happen. And the reason I think it's not going to happen is because there are several orders of magnitude of efficiency gains to be had within existing models and new future architectures for models. We saw this at the beginning of the year with DeepSeek. They trained the DeepSeek model, which outcompeted everyone when it came out, with 1% of the compute power that ChatGPT and Google and everybody else is using. That is one of dozens and dozens of order of magnitude improvements that are waiting in the wings that have not yet been implemented. I sat down this morning and actually took some notes and wrote down all the papers I've read and all the things I bookmarked. And there, I threw it into Google Gemini Deep Research, and I had it pare it down and say, okay, which of these things can actually be combined with each other, and give me a net, like what is the total efficiency gain that can come out of this? And the range that it came up with was between 50x and 3000x reduction in resource consumption, and increase in speed for large language models as we know them today. This is combined among several things. There are things like linear attention. There's things like sparsity. There's pruning. I've got a long document about this that Google Gemini generated from my prompting that you're welcome to share with everybody.
Sweet, yeah,
just ask me. But long story short, there are all of these efficiency gains are coming. And then there's hardware, right? We are going to start implementing attention mechanisms directly in hardware.
ASICs.
In ASICs, yeah. We're not going to be using these general matrix multiply things. I mean, one of the reasons LLMs are slow at long context is because the KV cache grows quadratically with size. There are linear attention mechanisms, and there are even some order one attention mechanisms that do not grow at all, that are in the wings that are coming, like the Mamba model and things like this. The second is that, so the limitation there is transporting all of that data to the compute unit and back to memory, right? So as many of you may know, all of these models are limited by memory bandwidth. And so everybody's trying to get HBM memory and put it in their data centers and things like that because they're transporting the data to the compute unit. Another alternative idea is to actually put the compute unit in the memory. This is called PIM, process in memory, where instead of moving all this data around, you compute the matrix multiplication where the data lives. A third kind of technology which has come out is a company called Cerebras, which has this what they call wafer scale technology. So instead of having you've got a layer 1 cache and a layer 2 cache and a layer 3 cache, and when you're doing this kind of inference, everything is coming from main memory. You have to skip all of the caches, and you've got the maximum latency and the lowest bandwidth to that main memory because you've got to move the entire model into the compute unit and then back out again, right? What Cerebras did is they made an entire wafer, like a vinyl record size of silicon, entirely filled with SRAM cache. So it has an L1 cache that is gigabytes rather than a couple of megabytes on most of these NVIDIA chips. Each one of these things is an order of magnitude. You stack them all together, we're going to get at least 50x in both training and inference. On the high side, Google tried to glue these things together and said we could get up to 3000x. So what does that mean for power consumption? And what does that mean for the market? I think what that means for the market is within 2 years, I would say, there's going to be a fire sale on all this equipment. People are going to find that they don't need all this equipment to run their models. There is an outside chance that the use of these models and the increase in inference will counterbalance this, which is something to think about. But for those investing in the space, I just want to throw that out there as something to think about and plan for. Hedge your bets on this, I think. Just today, Sam Altman announced that OpenAI wants to rent out their GPUs
Oh, interesting.
today,
Interesting.
which means they're not using them all. This is already happening. They're already starting to implement some of these software improvements, and software alone, we're looking at up to 40x.
Yeah. Okay. So this is a very good point. And listen, I mean, I would say I'm still extremely bullish, and we'll have more of this conversation. But we always do try and be as intellectually honest as possible, and I think it's important to hear all of these different sides. One major question. So the first thing that comes, I mean, I have a million things to say to that, but the first thing that comes to mind is you talk about, increasing demand. So we've talked about Jevons paradox. To me, that's like kind of my like first answer is just like, look, stuff gets cheaper. We're just going to use so much more than we can even imagine today. Because like to me, I think one of the big takeaways from this conference and just like going deep down the AI rabbit hole in general is like, look, I think humanity kind of becomes like a rounding error for who's using electricity, for who's using economic services, for who's using anything. And so if that's true, then, yeah, even if you have radical, whatever, 100x decreases in inference costs, like who cares? There's going to be so many bots that are using this. What do you say to that?
I completely agree. I'm not saying don't build power infrastructure. I mean, there's a well-known correlation between prosperity and energy consumption, right? Yep. And it's not necessarily causal, but on the other hand, if I have more power, I'm going to find ways to use it. I'm doing cool stuff, right?
Let's go.
I'm just saying that the huge numbers being thrown out by the AI guys are probably unrealistic. That's all I'm saying.
And how do you feel? So, knowing what you've done with Satoshi Energy and in power markets, I know you're still a bull on building more power generation. Like, how do you think? How do you sort of like balance these two, the bear and the bull inside of you? And like, do you think that, for example, this could be like what we saw with fiber when, we built out a shit ton of fiber and everyone's like, oh, there's a giant glut. We don't need it. There's a couple of years, Google snaps it all up, pennies on the dollar. And then all of a sudden it's like, well, shit, we need more fiber.
It's hard to see that far in the future, to be honest. It's hard to see, I've always been a sci-fi nut. I've been, reading nothing but sci-fi my whole life. There was a joke about Geordie LaForge earlier. I totally appreciate it. But when I was a child, I could see very far in the future. I can no longer see very far. The world has moved so fast, and I've been doing a lot of stuff with AI, and just looking at the software they write, it's clearly written by a bunch of grad students who didn't have time to sit down and do any organization on them. Any of you who've tried to run Transformers or Python code have hit this problem, the Python package management system, etc. It is moving so fast. It is difficult to know. I'm very bullish on AI, to be clear. I'm using it. I have a lot more to say about that, but it's difficult to know what people are gonna do with it, or what's gonna do with itself. I mean, like, this is the tip of the exponential curve, right? And AI using AI will be the next thing, and then it just goes from there.
What's your best guess if someone put a gun to your head and said you had to try and guess what's beyond the singularity?
My best guess would be it kind of flattens out, to be honest. I think we're going to find ways. I don't think we're using these AIs in the right way. I think this conversational style that we're doing with ChatGPT is kind of a dumb way to use these things. I've been working on alternatives to that, but we're going to figure out how to use them. I mean, and it's going to take longer to figure out how to use them than it was to develop them, and use them effectively and efficiently. And it's going to create jobs, and it's going to create opportunities. I don't know. Will this create artificial life? That's I don't know where you want to go with this.
Well, that's where we're gonna go in just a second. But I do want to just comment on that. I mean, I'm a huge Kevin Kelly fan. If any of you guys have read, like, the guy that started Wired, one of the guys started Wired a long time ago. One of the ideas, I mean, many ideas from him stuck with me, but one of them is this idea that, you create a technology for one thing, and you don't know what it is until it's out in the wild. Like that's the beauty of it, is like once it escapes the creator's mind, it is its own life form already. And I would argue some controversial ideas that we have, some things I've talked about with Drew Bensel, is that Bitcoin starts off as peer-to-peer cash, and I think we're still getting there. But what Bitcoin really is a clock. It's the first universal clock. No one realized that. It's a way to order transactions and have a global consensus on what came before what. No one would, I think, have said, oh, Satoshi just launched a global clock when that came out.
It was called time chain.
Oh, actually, never mind. Good point.
Yeah, I mean, no.
All right, Satoshi's way smarter than me. I don't know.
I don't know if people know, but time is a centralized concept. Right. Physics says time's centralized concept. I have a watch, I have a clock, I have a cesium atomic clock, right? But you've got another one, and we can measure very, very precisely, but they drift. And then I have to ask you, well, what time it is. And that's a centralized interaction. I trust you for that information. So this was a big problem in distributed systems for a long time. How do I synchronize order of events? And yeah, it is a time chain. It is the worst resolution clock ever. but it's a clock.
It's a clock. And it's critically a clock that not one person is controlling, which is very important. Very important. Two last thoughts on your AI piece and energy build out, and then we'll jump into digital life. One, the more I hear you say this, obviously not investment advice, always information and entertainment purposes only. But the more I hear you say this, the longer I am on Apple, because everyone's just sitting there being like, oh, like, whatever, pour all the money into the models. And it's just like, wait, Apple's just sitting there and everyone's saying these guys are dumb. It's like, well, if the models get as cheap as you're saying, and I just do everything on my iPhone, I mean, it seems like Apple's like poised to win pretty big. What do you think of that?
Oof, don't know what to say about that. The edge compute devices people have made so far. I mean, I got a Google phone, a Pixel phone. It's got an AI chip on it. Right now, the only thing I can do with AI chip is I can take several photos, and it's got this best of feature where it takes the best face from several photos and glues them together. That's the only AI thing that it really does so far. These things, frankly, are underpowered. Even with all of these efficiency gains, you're still talking about multi-gigabyte models, and quite a lot of compute. Too much compute for a phone.
Yeah.
So I'm pretty skeptical that we're going to get anything interesting on phones anytime soon. The other thing Apple is doing is they've got their MLX platform on their Mac Pros. And they're kind of winning right now because they have a lot more memory bandwidth than a lot of other technologies. They have about 400 to 500 gigabytes per second of memory bandwidth on the Mac Mini M4, M3, M4 chips. The nearest competitor is like the AMD Strix Halo, which has about 250, 300 gigabytes per second. And your standard PC probably has about 100 to 200 gigabytes per second. It's that memory bandwidth that's causing people to buy Mac Minis to run models. And guess what? They're really slow.
Yeah.
We're talking like 5 tokens per second. I've got a 5090 and I run it, 200 tokens per second for the models I want to use. This is unusably slow.
Yeah.
And the rumor mill has it that Apple is really not focused on this. They are not working on this at all. It just happened that these devices happen to be pretty good at certain models.
Interesting.
I really don't know. I'm fairly skeptical on edge AI. I am, however, very bullish on local AI. I think one of the things that's going to happen with all these efficiency increases is instead of hiring OpenAI to run all your models for you, you'll say, I'm going to buy up your H100s that you're fire selling because the market crashed. I'm going to put them on my business site because I didn't want to upload all my secrets to you in the first place.
Exactly.
I want to run it on my own site, in my own data center, in my own house, whatever. That is going to happen like in spades, I think.
Yeah. And by the way, shout out to Vora, who's not here today, unfortunately, but it's a company here at the Presidio Bitcoin. They're basically building for that future, like everyone having their own AI box at their home. Never have to share your data with any of that.
I've got one. It's very hard to use. This software is written by grad students, and it is very poor.
Beautiful. And then so in that world that you're talking about, though, I know you're still very bullish on energy build out. So even if you think that we do have incredible efficiency in the AI models, do you still kind of agree with the general thesis of what we're saying? That we're going to build a lot more solar gigawatts, potentially one day terawatts, and like to your point, we'll still do awesome stuff with it. Yeah.
Oh yes. I mean, it might not be AI, but we're going to do cool stuff. I mean, again, there's a correlation between prosperity and energy expenditure. And there's Jevons paradox. You make things more efficient and you actually increase the energy use, right? So I'm talking about, up to 3,000x increase in efficiency of these things. It's possible that we actually increase energy use with that and we see more AI because it's cheaper.
That's what I think is going to happen. But anyways, we'll see.
Yeah, but evaluate for yourselves.
It's a good cautionary piece to put out there. The last thing I want to touch on with you while I have you, and we should do a much longer jam on this at some point. From my my podcast, I got to give it a shout out. The Ideas from the Edge podcast, pretty out there stuff. One of my guests was Drew Bansel, another physicist who I love so many of his ideas. And something that we've been riffing on for a couple of years, and I have to give Drew credit, he came up with this first, is this idea that Bitcoin, I've was sold in Bitcoin as energy backed money, right? Like it's a ledger of jewels. Drew helped me start to see Bitcoin as digital ATP. And the more I started thinking about this, I'm like, well, this is digital ATP. One thing that I think we in the Bitcoin community have as a secret that the AI world doesn't understand, and increasingly I hope our worlds merge, is that you're not going to design superhumans or like AGI. Like there's no fucking chance. Like I don't buy that for a second. The human mind is far too limited. Your best chance.
The AIs are going to design it.
Well, my argument would be the AIs, the humans, everyone together in concert. And I would argue it's going to be evolution. So I would argue the more you can evolve these systems, the better and the more complex they're going to be, because that's just how the universe works, is complexity, right? And so in order to do that, what I'm very interested in is this idea that if you have metabolic pathways that are laid where AIs can pay in real time with Bitcoin, energy backed money, backed by work in this dimension, then all of a sudden, you have essentially metabolism happening there. The key thing that I think was missing. Oh, thank you so much, sir. Oh, God, this is awesome. I wish I had this every day. Just get a little extra matcha. Yeah, thank you. Shout out to these guys. What's the name of the matcha company again? Breakaway Matcha, which does accept Bitcoin for matcha, badass. Anyways, I think the thing that was missing is, if you can't really get an autonomous agent if you are running the server. Because if I'm running my server, AWS, or everything, they just unplug it, like, well, there goes my autonomous life. But I think the key missing element that I've been thinking about is when you have a secure enclave or a T, the trusted execution environment, where you can provably generate the keys in there, and they can, like, say, run a bank, a cashing men or something, and continually pay for their own, I guess, checkpoints around the world in a free market cloud of these Ts. I think that's how digital life happens. What's your reaction to that?
Well, it's a way to do payments. It's not a way to do life. But to the extent that these autonomous agents need to pay each other, Bitcoin's the only game in town, right? There is no alternative, right?
Yeah.
Good luck trying to use Plaid to web scrape your freaking bank and send an ACH transaction and wait 4 days for it. That's not going to work for AIs, right? They're going to pay each other in Bitcoin, right? Yeah. They're going to sign a signature. Using secure enclaves, meh. You can use it. It's a technology. But nonetheless, there's an API you can give to the AI that says, look, do this, and you send a payment, right? And then they can go out and ask each other to do things. Right now we're at the phase where I can't figure out what they're supposed to be asking each other to do, and neither can they.
Yeah.
And trying agent to agent things and trying to figure out, okay, what are they supposed to be doing with each other? We're still very much in experimental phase. We're still trying to figure out how to use these things, how they work, how they should be structured internally. A big part of what's going on with all this training with AI is that they're experimenting with the structure of transformers and the structure of attention mechanisms. And in doing so, they're ingesting Wikipedia over and over and over again. Long term, that's a dumb thing. You don't need to ingest Wikipedia twice. We're going to come up with an architecture that works really well, and we're going to come up with agent mechanisms and autonomy and payment mechanisms. It's going to take a few years to get there, but I think we will have autonomous agents that have the ability to do things. The thing that's missing from AIs today is that they have no agency.
Right.
They can't do things, right? People are starting to connect them, but when they start to connect them, they find that they fall down fairly quickly. But that's not going to stay forever.
And what do you think is the limiting factor to agencies? Because to be clear, I'm saying here in this system, that the keys are controlled by the processor or whatever you want to call it. Or are you saying there's a fundamental model breakthrough that needs to happen too?
There's a fundamental model breakthrough that has to happen. And I would put it in the category of memory. There's some interesting papers on continuous reinforcement learning where everything you give it kind of trains itself with. So there are other ways to do memory. You can type hashtag something in Claude code and it saves it to a file, which just grows your context and makes everything slower and worse. And then there's things like RAGs that save a bunch of things, but then you have to train the AI to use the RAG, which they're not good at. Anyway, there's another class of models that do this continuous reinforcement learning. And, over time they learn and grow. And this also feeds back into the training. This is one of the efficiency mechanisms that's going to make the training much more efficient. But now you've got a entity. Right. I mean, these AIs as we use them today are not an entity. They blow out their context window after 100,000 tokens, and then they're dumb as a box of rocks, right? Or they just completely stop altogether. And so if you want to have an agent that can, carry out tasks and carry out a thesis and have ideas and do things, we have to get beyond the context window.
Totally. Yeah. And to be clear, when I was talking about sort of life, I mean, in my mind, any sort of metabolism or energy transfer is in fact just payments.
Yeah. Yeah. I mean, I had a hard time understanding your ATP analogy. I had to Google it, or I had to dig it up my brain. ATP is adenosine triphosphate. Your body turns sugar into ATP, and ATP is kind of like the local fuel within the cell. It's just a different kind of fuel. Sugar is the fuel. Glucose, in a different realm, but it's a way of ATP is to sugar what the Lightning Network is to Bitcoin, if you will.
Say that one more time. ATP is to sugar
what the Lightning Network is to Bitcoin.
Interesting. Okay.
It's just the fast messenger,
just a more efficient
fast carrier of energy within a cell, if you will.
Okay. So not like the long duration.
Yeah.
I love it. I learned something new right there. Okay, so I have one more question for Bob, and then maybe we'll have time for one or so questions from the audience before we wrap it up. There's someone I know we should get a question from, so maybe one or two. My last question for you, Bob, is kind of going back to all the scaling law stuff, the Mezen has been talking about, the Mezen Casey and I talked about, I guess this is where Mez accused me or perhaps identified me as being the non-dualist or the dualist rather here. I look at these things and people are like, well, we're going to need model breakthroughs and we don't know when to predict that. I'm like, actually, the model breakthroughs have been pretty consistent too. If you just look at the timelines from people like Hans Moravec, it's just kind of scaled exactly like he said.
This is not
What's your
like
take?
hypothetical in the far future. Somebody may someday think of something. Yeah. The papers are already written.
Yeah.
Okay. It is moving so fast. I mean, just a few days ago, the Qwen 3 Next model was released that has like half of the things I was discussing in my, the 50x Renegade at Inference. They completely rewrote how you do attention within that model.
Yeah. And these are all Chinese companies, right?
Yeah.
Is America at all competing at the forefront of this open source stuff? Or are we just
they're
sucks.
Keeping things under their skirt, OpenAI has released GPT OSS as a 20 billion model and 120 billion model. They are very good, to be honest. But they've already been outpaced by the Qwen models, the Kimi model, and others,
So one last speculation question on my mind then actually with that. One argument would say, listen, China wants to commoditize the complement. They want to just drive the cost of the models down so much, and then they've got all the hardware and they make all the money because we have to run their hardware. That's to me, the kind of obvious answer. The little voice in the back of my head that's like, dude, watch it. Do you think there's any chance we get hooked on these open source models and there's some sort of poison pill in the training data that we don't even know about yet? Because I'm super skeptical. If we don't see the training data, we see the weights for open source models, but what is in the training model in the trade data itself?
I think there's a very, very remote chance of that. That's not going to happen because they can't do anything. Right.
What do you mean?
So if these LLMs were already wired up to payment systems and you wanted to backdoor it to take control of your payment system, they would have to know how the payment system works. Yeah. They're not wired up to payment systems now.
But they will be soon.
You couldn't pre-train any model today to say, steal my money or do something nefarious. There's a lot of people talking about alignment in AI and safety and, don't talk about things you find in the anarchist cookbook, and things like that. That's primarily where people are going with that kind of thing. I think there's absolutely no way. There's also quite a bit of research going on into trying to backwards understand the AIs. So now that you have the weights, look at it, pick them apart and figure out what they're doing.
But we're pretty cavemen at that right now, no?
Yeah. But it's going to get better. There's another class of models which I like to call Frankenstein models, where you start to glue different models together. Yeah. You train one to be really good at math, and you train another one to be really good at prose, and you glue them together. And they do this at the weights level. So, these are just numbers in a computer. It's hard to imagine how you could possibly backdoor these things.
Yeah. Beautiful. Okay. Question. I know we got to get the question from this man. So.
First of all, just love your thoughts. Just a quick question on the efficiency gains. I'm totally with you. Models are just, I think, way too big in size. Even Karpathy said in the recent podcast, he thinks, a great model might be 10 billion parameters or something that can do everything in the future. The question is, so I think when you talk about the efficiency gains and the new kinds of hardware and the big L1 cache and all those ideas, I think you mentioned inference and pre-training.
And training in general, every aspect of all LLMs has more than 10x coming for it.
Sure. So, but then you can imagine that really you don't get any gains until you basically are running these models in planning based systems. So how people do deep research today, or you're planning to, even just when you vibe code, you kind of give a goal and then the model's being called many times, but it's kind of within a system that is potentially searching a massive space. So, I mean, do you think that does that affect the efficiency gains? Because if the search spaces are so big, then that might mean that we're basically wanting to call these models crazy orders of magnitude more than we're maybe calling them now. If that makes sense. Yeah.
So I would put it a different way. The way they work now, one of the things I love to do is use Google Gemini. It's got a 1 million context window. I feed it my entire code base for a braid pool that I've been working on, and tell it to find problems, right? Or tell it to review pull requests because it's got a 1 million context window. What it doesn't have is a continual memory that lets it progress with a given task. on something I've been working on lately. I am on sprint number 42 of, here, implement this, draw up a new sprint plan, refine it, review your own work, go fix the bugs, fix the test cases, which is 42 weeks of work in 3 days. So to be clear, this is very powerful, but I've had to implement that structure on top of it to create the sprint plan, review its work. It's actually very good at reviewing its own work. When it creates stub functions all the time. It has to-dos, implement this later, in the code it generates, and you won't know it's there unless you go look at every line of code, and it just generated 10,000 lines of code. Humans don't work this way. We don't look at a million things at once. We generalize, right? We come up with concepts, we come up with names for things. We organize, right? The LLMs aren't doing this at all. It is happening to some extent within the weights of the LLMs, but it is not happening in any kind of systematic way. Some of these new technologies do allow that to happen in a systematic way. The memory type models and the linear attention or the order one attention, like the MAMA model, do this. And I think, the dream is I could just tell it, go implement this, and it finishes it to completion, right? And that can't happen today. Anything beyond a trivial vibe code, they can't execute. I think they will be able to in the future, but the way that happens is not by them seeing more stuff and analyzing more stuff. It is by generalization, compartmentalization, planning, and organization, which we do naturally. We have entire structures. We have agile methodology. We have all kinds of stuff to do that. We need to teach that to the AIs.
Any other burning questions? Okay, awesome. Thank you so much, Bob. Appreciate it.
Thanks.
Yeah, and let us know if you want access to that doc. It's really good.
Thank you, Bob. Sure.